Okay. I'll briefly mention what research data management is and what do we consider as data. I will delve into FAIR principles related to the data and how do we start to make our data more reusable. So what are the basic RDM best practices? And we'll have a little bit of a discussion at the end about FAIR versus open and what kind of challenges people might face with that. My slides are linked in the HackMD, so feel free to download them. And yeah, so I frequently get asked this question, what is research data management and what do we do? Briefly, research data management refers to the process of organizing, storing, preserving, and sharing data that's collected during a research project. So this also includes the everyday management of data during the lifetime of the project, but it also extends to include the decisions on what will happen to that data beyond the project completion. So for instance, where will this data be deposited? How will it be shared? And many other questions. So this is research data management in a way is embedded as part of the research process. But now that I've mentioned the term data, it can mean different things to who I'm, depending on the context and who I'm talking to as well. So what do I mean by data when I'm, for today's purpose? It's any type of information that is collected, observed, or created in the context of research. As such, it can be primary data, that meaning that it's the raw measurements from instrument reads. It can be the secondary data as processed from analysis and interpretation, or it can be a published data that is available for use by others. But essentially, it also includes metadata, which is the data about your data. So in a nutshell, it is everything that you need to validate, reproduce your research findings, as well. What do we need to understand? What kind of information do we need to understand the data and handle it properly? So to that end, I know that some of you might be bioinformaticians in the group, so I would love to ask all of you, do you consider software as data? And take a minute and let us know in the chat. So if you think software is data, type 1 in the chat. If it's not data, type 0. Let's see, have a look. All right. Right. So I see there's some consensus here that it is data, and you're not wrong. You're absolutely right. It is data, but it's not just data. So it isn't in a way, because while data in the computing sense is something that can be processed by a computer, software is a very special type of data. It in a way that it can be creative, executable tool that operates on data. So just in the scope of today's session, when I use the term software, we refer to algorithms, scripts, source codes, and packages that are used in research. But we're not referring to software that is frequently used, such as MATLAB or word processing or Excel sheets. That's not what I mean by software in the scope of today's session. But I also realize we don't have much time together, so I'm going to focus on the FAIR data principles, and we'll have some. We wouldn't have time to delve into the software side of things, but I have included several slides on FAIR principles relating to software at the end of my talk. So if you go to the slides link in the HackMD and download that presentation, at the very end, you'll find some more material there that I'm not going to go into too much. So FAIR principles, what do I mean by that? It is a set of principles. It's to define the best practices for both data and software to facilitate the discovery, access, and reuse, both by humans and machines. So it's not a set of rules per se, it's not a standard, it's an evolving process, and it's a vision. And that's why when we talk about FAIR, we usually talk about it in the level of fairness. And FAIR stands for findable, accessible, interoperable, and reusable. So let's delve a little deeper into each one of those principles. First of all, findable. It means that your data should be findable by you and others. It means that the data should be available in a discoverable resource, have appropriate descriptions, have a persistent identifier. And when I'm talking about data, I also talk about metadata. So both the data and the metadata should have persistent identifiers that where they live, an address where you can find them, and a URL is not a persistent identifier, a DOI is. So whenever possible, deposit the data in a domain-specific repository related to your field. For instance, if I'm working in a biological field or a cancer research field, I deposit my data related to that field somewhere where my peers can find it. So preferably in a similar, in a popular repository, and you can find the repository finders in the link here to find exactly what's the most common repository where people in your field deposit in. So if that's not available, or sometimes it's not, you deposit your data in a general purpose repository. For instance, I've deposited my today's presentation on Zenodo. There's also Dryad, there's also Dataverse, and many more. And I cannot stress this enough. And I'm talking about data. I'm also saying this goes for your data and your metadata. So that's about findable. What about accessibility? So it means that the data should be accessible for both humans and machines. It have to be retrievable and understandable. And to that end, depositing the data under very defined conditions for others to find it means it's accessible, for instance, at HTTP or an API. Adding clear licenses on who is allowed to access this data, what they are allowed to do with it is very important. Specify what the users need to do to get access. Sometimes we have requirements, for instance, like two-factor authentications, or you have to request access from author. And ideally, this kind of access information is also embedded in a machine-readable format, so a machine can automatically translate those requirements. For instance, private and sensitive data, you might not want to put that out and there are restrictions on it, but the metadata or the information about that kind of data should be available and accessible. So just a couple of things to remember about this, that if the data doesn't have a license, it doesn't mean that it's free. It actually means quite the opposite. It means that it's no license, no access. And what we're trying to achieve here is to have the data as open as possible, but as closed as necessary. So, and I'm going to touch a bit more on that concept here because, and compare fair and openness. But that essentially means that even if you have a heavily protected and private data, it can be fair. So, interoperability. Interoperability in a nutshell, ask yourself this: will a machine be able to understand what I'm saying? With the advancement of AI and machine learning, we want the machines to be able to accurately understand and interpret that data. And this is one of the most important principles, but also one of the most difficult principles to apply. But there are ways to go about this. So describe your data in detail, that's in metadata. Describe it properly using controlled vocabulary and ontologies and standardized terminologies, preferably from your field. Also use file formats and preferred file formats and open file formats whenever possible. Having your data locked up in a proprietary or a commercial file format means that other people won't be able to access it or open it or make use of it. So the last principle is reusability. And ultimately, everything you've done in the findability, accessibility, interoperability leads to your data being reusable. So everything you've done so far leads to this point, and to ensure that others and yourself can use this data. And we're going to touch up on this a little bit. But I would like, for now, I'd like to summarize what we've talked about. First of all, deposit the data where others can find it, have a unique identifier, persistent unique identifier, make your data and metadata accessible via standard means such as HTTP and APIs, create metadata and explain it in detail and outlining what this data is about. Never assume that people know what you're talking about. Deposit the metadata with a persistent identifier and make it available. And this is especially important when you cannot share the data itself. Include information on ownership and provenance. Outline what the other people who want to use your data, what they are allowed to do with it and what they are not allowed to do with it. So clear licensing, like MIT or Creative Commons license is very important, but your license choice might be guided by your institute, your funders' requirements, even on a higher level. Check the requirements before choosing the license, but do not leave it without license because you're essentially locking it. Specify the conditions as an authentication or authorization that is required, and describe the data in standardized fashion from terminology and vocabulary that is used in your field, and share it in the preferred and open file format. Last thing I want to stress here is start this process early on. This is extremely important because it saves you time down the line. And I hope I've convinced you by now that making the data, why you should be investing time in an effort making the data reusable. So if you're not really sold on it yet, let me ask you one question. Why would you make the data reusable? If you can remember what you've done a year ago, then you don't need this. But one good reason to do this is that you are the first person to reuse your own data, and you need to understand what you've done a year ago, and your colleagues need to understand what you've done a year ago as well. Because researchers, we're not alone. We work and rely on collaborations, and all of this ecosystem needs to understand what exactly occurred and how you went about it. So I always say research data management starts at home, and it starts early on, and there's simple things or multiple things that you can do that become a habit in the long run. So for instance, organizing your data in a logical manner, separating the data according to type, that can be very useful, and use hierarchical structure. So a clear directory structure will make it easier to find the files and the versions. And this is extremely important when you have collaborative work with others. So one of the hierarchical file structures that we usually recommend is starting from broad topics to more specific ones with in a nested way. But at the same time, restrict the level of the folders to 3 to 4 and items to maximum 50 items inside of each folder. Obviously, for different projects, that might you might have a different structure, but whatever structure that works for you, and document it and be consistent. So that's the ideal way. File naming. A file is the primary identifier, and I should be able to know what is in the file before I click on it. This should be unique and consistent and descriptive. And this will allow for increased visibility and discoverability and can be used to easily classify and sort files. So that will, again, save you a lot of time and effort in the long run, especially if you're automating things. So if you're automating a certain action or have a little code running for a specific type of files, naming them consistently will make life so much easier. I spoke a little bit about open file formats and in general preferred file formats. In reality, during the research, the choice of file formats might be dictated by convenience or the instrument provider or just what everybody around you is doing, right? So what's the rest of the team doing? But to make the data, once you get to that stage when you need to make the data available for others outside of your ecosystem, is choose a file format that is most commonly used and is open to allow for that interoperability, to allow people to be able to take it on and reuse your data. And there are some guidelines on which format for what kind of documents, so feel free to browse these. And then I've also mentioned, like, we work in ecosystems and we work in collaboration. So one handy way of doing this is having a version control strategy that allows you to detect the most current version. So what we need is essentially to keep track of the changes that people have made to the file or a data set, to see who did what and when. And for that, the version control strategy is extremely important. So organizing and managing the records will also save time and effort in the long term, and you will not you will end up not losing important information that you might have otherwise missed. So people ask, what should I include? You know, like we've talked about documenting and giving contextual information about the data, but what do we actually put in there? So that's what we call metadata, and that's essentially who created this, who owns the data, what kind of content do I expect in here, what are the output and the results, right? And when was it created? Which version of this data am I looking at? Where is it stored? Where can I find it? Where was it published? What kind of methods were used and instruments, and essentially how the whole data set was created and analyzed. And again, licenses. How can I use this data? What am I allowed to do and what am I not allowed to do with this data? And I've been talking about this FAIR and sharing it, but FAIR does not essentially mean that you have to share everything. It does not essentially mean open. And by open, I mean that open data is the data that can be freely used. When we think about FAIR and open, we usually think about open, that is something that is available online for anyone to use and distribute, and subject to only like the minimum requirements of attribution or share alike. But FAIR is not open. FAIR is the open data needs to be fair in order for it to be useful. And making your data and software out there in the field, or out there freely available, does not mean that it means that it has value, and value of reusability value. So just to be clear, we need detailed contextual information about that gives us the background of how this data was created, how we're allowed to use it, and quality control. So essentially, if I would like to use this openly available data, I need to know that it's of good quality, and to ensure that I can use it for my own purposes. And for that, we need it to be fair. So in a nutshell, the FAIR data motto is to be as open as possible and as closed as necessary. And ideally, what we want is fair data and software that is shared openly. That means good quality data and software that is available out there for everybody. But I do hear a lot of challenges or inhibitions to sharing data openly. So I would like to ask you and our audience today, what kind of challenges or what holds you back from sharing the data openly? Let us know in the chat. I'll give it a couple minutes to see and to see this your arguments. Anyone? Okay. So this is a tough one. Yeah, privacy issues. Right. So yeah, as I said, this is a tough one. And two of the most common arguments that I get to hear is that I'll be scooped. Yeah, people are going to take my data and run with it. But in reality, there's very little evidence to support this. And sharing your data openly actually ensures quite the opposite scenario. Because with appropriate licenses, you ensure your claim of authorship. And this has been one of the major driving factors behind the publications of preprint. Everybody who has data of value wants to be the first one to claim their ownership to it and put it out there as soon as possible with a clear license and provenance details. So it's counterintuitive to the old adage of, yeah, I'll be scooped. But in reality, this is not what happens. And we've seen evidence of this in the success of preprints. Another issue, another sort of challenge that I hear from people is that, what if someone takes my data and misinterprets it? Which is fair enough. It's a valid fear. It's very, very valid. But adding that clear and detailed information and documentation is the one key to ensure that this doesn't happen, including rich metadata outlining exactly what you did, what happened, ensures that there is no room for misinterpretation. And include your ORCID ID, so include details on how to allow for someone who would like to get in touch to inquire about that, to do so before making any judgments. And we see this in papers without code, for instance, where people submit a paper asking for clarifications or asking for the data behind it. And then the people behind papers without code, they do get in touch with the authors, giving them a chance to respond. And this is the right way to do it. That's how you ensure that once you put your data out there and your contact details, people will not have an excuse to misinterpret anymore. So I can talk a lot more about that, but for today, I'm gonna just wrap it up and say, if you want to find out more, please download the slides. And there's a full day workshop material on research data management practices that's available here. If you do download them, please let me know how you get on, and I'm happy to answer any questions. And last but not least, I would like to thank my whole team at the SciLife Lab. So so thank you so much. And if you have any questions, please feel free to ask. Sorry, what is? Sorry, so can someone? There's a question in the chat. What is a trend or feature that I missed? In what sense? I'm not entirely sure. So can you please elaborate?
Sarah, I think it's a fear of what if someone gets to see a trend or feature in the data that you missed, or like a mistake or something that you missed. Like it's a fear. I think it's a response to your question previously.
Oh, I see, I see. Um, right. So if it's a trend or something that you missed, best case scenario, that person will get in touch with you and you'll start up collaborating, right? Worst case scenario, they are gonna correct it and build on that while citing you and mm, saying, okay, so this is the original data, this is the original person who did this and created this. And mistakes happen all the time. Mistakes in research happen all the time. Once it's corrected, it's the right way to go about it. Because if it just goes uncorrected or unnoticed, we end up with the catastrophic results. And we've seen this in many cases where big name researchers have quite, have quite catastrophic consequences to incorrect results. What can you do when you share data with someone like a reviewer who asks for it to validate? What can you do when you share data with someone like a reviewer who asks for it to validate your findings, but you end up being scooped? So at this point, the data is with a reviewer, pre-review. Put it out before, preprint. Put it out there before you get it in another process. That way you have a DOI and you have a record of it being out there even before.
Yeah. Thank you, Dr. Sara. We and agree that we'll take the questions and record them somewhere, and then they can also be part of the discussion. Yeah, we'll also talk more about that in our open discussions. Thank you for the nice presentation. And right now we'll head over to the next presentation by Ziyaad Parker. So Ziyaad is a computer scientist who is currently working with H3 Bionet as a data manager to solve many challenges of submitting terabytes and petabytes of genomic data to the European Genome Archive. His interests are in using deep learning and artificial intelligence on big data to solve global unique problems that can improve people's lives. Welcome, Ziyaad Parker, for the presentation.
Hi everyone, my name is Ziyaad. Just a quick show of my camera. I'm going to switch the camera off because sometimes there is a bit of a lag during the presentation. So that's me. So what I'm going to be discussing in today, it's also a fair data, but mainly at H3A Bionet. And what I will do is there are some slides that overlaps with what Dr. Sara was speaking about. So I will skip those to save time a little bit, and then I'll spend more time on some of the slides that wasn't spoken about in the earlier presentation. For example, the software side of fair data. So what is H3A Bionet? So H3A Bionet was established to develop bioinformatics capacity in Africa, and specifically to enable genomics data analysis by a consortium of H3 Africa researchers across the African continent. It was established about 10 years ago, and it's been running throughout. I've been part of H3A Bionet for the last, I think, since 2016. So that's been the start of my journey. So H3A Bionet is also developing human capacity through training and support for data analysis, and facilitating access to informatics infrastructure by developing or providing access to pipelines and tools for human microbiome and pathogen genomic data analysis. Faisal, who's going to be speaking next, he's also part of H3A BioNet. So the background. So basically, more and more data is being generated all the time on a consistent basis. I mean, all these different big websites like Facebook, Twitter, every day more and more uh, data is being generated. And the question comes around is researchers are tackling difficult questions to ask on large data set. And this is where data management is becoming very important. Um, and this is why there's a need for sharing and reusing of data. So the problems with the current approach is that when the data is generated, no, sometimes the data is hard to find. If it gets put online, the documentation might not be there, or it's one line explaining what to do, and the next person is not able to go and use it, and also nobody is aware that it is online. When it comes to code, when people in general, developers code, sometimes the code is kept, again, it's also not well documented, and that's a common thing within the programming industry. A lot of programs get coded, and documentation is very rare because people are mainly focusing on the code and not on the documentation. That most of the time it gets done slightly afterwards, after the code, because the code is more important than the documentation. But it shouldn't be like that. The documentation is supposed to be equally important as the code. So what happens when the person? What happens if the person responsible? What happens if the person resigns from the job, or is in a car accident, or loses the hard drive, password, or some of the documents is password protected? Those are the questions that come around, and that's where it's important. Like Sara was saying, is that getting it as soon as you generate your data, and the code is to make it fair from the get go. Because if something happens along the way, at least it's there and it's available. Um, yeah, one of the problems is that currently in the community there is a little bit of motivation in the community to go and share and submit documentation. So within H3A BioNet, so it's been happening since last year. We've been developing different tools and packages to help people within BioNet to make different projects available and fair. For example, the project that I'm dealing with, the H3 Africa archive, that where data is submitted from the various H3 Africa sites from the different countries. That is now that since it could have been last year, where it's every step is being made fair, and these different ontologies describe the different data sets within the H3 Africa studies. So there's different data repositories out there to choose from, and this is just two examples of very good repositories that basically has the different variations of what we call good and quality. Is basically if they have an API that I'll go through in the next few slides. But if you look at space physics, data facility, and GenBank, it's classified as good. So data management means to plan, collect, describe, analyze, publish, and access. And when the data is downloaded, it needs to be easily available to download it with no complicated software to use. So, for example, if I use an example like Python, it's widely used and it's not complicated. in terms of documentation for how to use Python is basically all over the internet. If you, not all over, but if you go on Google and you go and look on how to use Python, it should take anybody maybe a day to get up and running, and that is not complicated. An example of complicated software would be something that you have to pay for. So can't think of any example off the back of my head right now, but for example, you have to pay like $100,000 or something for that software. That is defined as complicated and makes it difficult for the next person to go and use. So percentage of time spent finding and organizing data, according to research data specialists, is 79%, and that is quite a lot of time to spend looking and organizing data, and technically it should go down to about to 20 or 30%, if most data is there and preserved and easily findable. So like Sara was saying, it's as open as possible and as closed as necessary, and it should follow good quality and scientific practice. And these are the data principles by Force 11. FAIR means findable, accessible, interoperable, and reusable. So findable meaning the metadata and the data is described and indexed in a searchable resource with a specific data identifier. So before submitting and putting it out there, it needs to there needs to be the indexes available with the specific PIDs. This over here is an example of using DOIs and putting it out there. It's basically a digital object identifier that is an international and recognized standard. Then when it comes to data sets, when it comes to the metadata, make sure it contains as much information as possible. So the data set's context, the quality, condition, and characteristics. And the important part is make sure it is understandable by researchers from a different discipline. So if possible, ask somebody from a different discipline to go and proofread it. So if they're reading it, they should be able to understand it by not spending a lot of time. I know there's different terminologies in different contexts, in different disciplines, and sometimes it means something differently in a different discipline. So it would be good to also include some sort of dictionary as well in the metadata. This over here is an example of using PIDs when referencing. So to be accessible, it means that the metadata is retrievable by the identifier using a standardized protocol. The protocol is basically a website. It needs to be open and free, and authentication and authorization. And that's basically what most websites have these days. And the metadata must remain accessible even when the data is no longer available. So if you go and you submit your data today, and somehow the server crashes on their side, as long as the metadata is still available, that's fine. Okay, so now I'll get to the software side of it. So basically, in order to make software more fair, we use a tool called Git, and the web interface is basically web interface version is basically GitHub. That's the one H3A Bionet uses at the moment. And if you go onto the link over here, github.com/H3A Bionet, this is a list of all the software that is currently available on GitHub. There are other tools that there's GitLab, there's Bitbucket, and others, but the most popular is still GitHub, and that is for making a code available. You can also put data on there, but very small data sets. There is a size limitation. But most people put in small sets of data just to show an example of how to run the code. It's not the actual data that goes into these repositories. Yeah, so it's about both. It's about making the data available as well as the code. Needs to be in a specific format that anybody is able to download and use. Common formats is in terms of data, which we'll get to in the next few slides. So basically, Git is basically, it manages a project or a set of files as they change over time. It gets stored in a data structure known as a repository. So you get a code repository and you get a data repository. That's the link. There are other features as well of GitHub, which I won't go through. Then tracking down changes. There's a language tool, Markdown. Instead of using Markdown is basically like HTML. It's a step further of HTML, which you can use to go and build documentation with, and you can also build websites on GitHub as well to host. It's free hosting. So let me go to and show you the GitHub Bionet repository. So this over here, can you all see the screen? I'm on the browser to showcase the different repositories within the Bionet GitHub account.
Yes, we can.
See. Sorry?
Yes, we can see.
Okay, good. So if we go through here, this is the Bionet repository. Currently, there's 48 repositories. There are 80 people working in the organization that are using GitHub, and there are 10 teams in total. If we go to anyone, so if you look at the right-hand side, there is this green graph. It's the shows the past year of activity. This is the actually a GWAS Docker. Then there's this one, the GWAS pipeline. It was updated 6 days ago. This looks like it looks very active. So if we go and we click on this, then there's the catalog, which I work on. Then there's lots. Then there's also another one which we can look at. It's the of a good example of how they use Markdown is the machine learning repository. But let's go. If we click on, so how it gets done in terms of version control, it shows you on the right hand side exactly when it was updated. So example, this folder was updated 2 years ago, whereas we can go to 29 days ago, which is this folder, a sock folder. So then if we, it's basically all the changes that was pushed to the repository, and it's currently, what was it? It was 954 commits, and this shows exactly what the person did and how it was changed. So if we click on any of these, this is the author that made the change. So he deleted bug on replication using a different version of GWAS catalog by Jean. Then we have another person by Scott Hazelhurst who made another change. So if we click on this change, and we click on this change, we can see exactly what was changed over time. The red is what was deleted, the green is what was added. And as well, yeah, the red was what was deleted, the green what was added. So that then if I won't do any more clicking on the side, but basically these are the commits, the commit IDs of the repositories. Then if we click on issues, it also shows all the issues and people need to respond to. Then if we go down over here, this is using Markdown to create this documentation on how to use the code. And this repository here, as you can see, this explains directly on how to use the pipeline. Sometimes it can take a little bit longer to use the software, especially if you haven't used the tools before, like for example R or Python or Nextcloud, because there's a learning curve of learning to use those packages first before running a GWAS pipeline. So if we go through all this, so as you can see, this is very similar to Microsoft Word or HTML. For those of you that know how to use HTML, in terms of putting out documentation, it explains this very well in terms of the features, the goals of GWAS pipeline, and exactly how to go about using it. So for example, like this, there's a lot of documentation. Sometimes it could take a lot of time to actually get in to learn and to go about using it. Here's another tool that also it took me about a half a day to learn how to use Docker. Nextflow I've used once or twice. So here we go. So how to install Docker? Sorry, how to install GWAS? It explains directly how, and you can do it on Amazon EC2, and it says you need to have credits. Then here's the prerequisites. Now it says here you need to have Java 8, Nextflow, and then there's also dependencies. So basically, this explains exactly how to go about running it, and there's a lot of documentation on here. And sometimes if there is an issue, you just go to issues. Sometimes somebody else would have had the same issue that you've had, and if you just do a search on here before you go to Google, first come here and read through any issues that they've experienced, because most of the time the solutions are here because somebody else has experienced it before. If it's not here, then it could be a problem with the underlying software, for example, R or Python or Nextflow, and that you'd need to go onto their website documentation. Then this is the machine learning glossary. So there's one less issue, and there's a reason why there's one issue only. And there's a reason why. Okay, this is not even an issue. This is just a request. It's just being logged as an issue. So this is make pre-processing example pages interactive. So what this person wants is the pages to be interactive. So if we actually click on, I think this is the website. If we click on here, so this is the website. So basically, if you click on here, it takes us back to the GitHub repository, and this over here. So all of this is built using Markdown on the GitHub repository. So if you want to build the exact same thing as this, all you have to do is go to this link, H3A Bionet, the ML glossary, and download the code. Here's the link, git clone with a command, and download the repository. You can even just click on zip, which is not that. Sometimes then you have to unzip it again, but I always just do git clone and download the repository. And as you can see, HTML, this is what they're referring to Markdown. So here again, here's the documentation on how to run the website. So you do git clone, like I said, Yeah, you just copy and paste these commands. Very easy. This could take a few minutes. So copy and paste this. Go into the cloned repository. Okay, so make sure Ruby is installed. If it is already installed, it should go quick. If it's not installed, you have to install it by going to the website and then running this command, and then the website should run immediately. And there's some notes that you can read as well. And yeah, that's the machine learning repository. It will look exactly like this. Yeah, so let's get back to the slides. So as a programmer, or sorry, as a scientist, as far as possible, do things programmatically using web services or modules. API, so API can connect to any language of choice. Then if people are sometimes requesting data via email, just if they do send it, if they are sending it, make sure that there is a password on it. Yeah, then so interoperable. So this is where metadata must be formal, accessible, shared, and it must use specific vocabulary with qualified references. So, like Sara said earlier, it needs to be in specific machine readable formats. There are lots out there. What I use on a daily basis is JSON, XML, CSV, and TSV for machine readable. Then this is just an example of how you can have outside, or you can have it by results, group it by results or figures, and put the code in the directory code data results in directory, or you can even combine the two and put the figures. Sorry, put the step 1 and step 2 inside the steps you're taking to generate what you need. You can put it inside the code directory. So making sure, so this when you're getting a new data set and you want to combine the two, put in you can put in how it relates to it. So is a new version or how it relates to it. If it is a new version, or another example is it the child version? Is it however it is related to it? So to be reusable, metadata must have a plurality of accurate and relevant attributes. It needs to specify provenance and go according to community standards, as well as have a license. Like I said earlier, be as detailed as possible. Research from a different discipline. Specify whether raw or processed data, so it needs to be specified, and using a reference manager. So setting a license. So if you need one, there are various licenses that you can find online and GitHub as well. So if you're putting a license on GitHub, there is a specific format that you can use to add in a license, and there are different examples if you need to get a license from GitHub for your code. So so the benefits of sharing and publication in good repositories, it makes the data is kept in a secure environment, and this is, again, it's good data repositories. So make sure that they are connecting to API, make sure it is secure, but yeah, it's always good to read the terms and conditions and see what they are doing. So make sure that the data is regularly backed up and preserved. Data can be easily discovered by search engines. So, for example, for the EGA, the data that I submit to EGA, that is discoverable by a search engine, as well as the catalog, which I'll describe now, when we get there. Intellectual property rights and licensing of data must be managed. And then also the usage monitored. So, for example, if they have a tool that can monitor the usage of the data. So when the data is submitted, it enables more use from other people around the world, and it increases the person who uploaded it. It increases their credibility and reputation. So the H3 Africa catalog is basically all the data that has been submitted to the EGA, which is what I've been working with for the last few years, is getting the data from the different projects in H3 Africa to go to the EGA as well as the H3 Africa catalog. So if we go to this link, and even when we go to the code for the link, sorry, we can't actually, it's not actually made public as yet, but it is in the process of getting publicly available, where other people can go and use the code. So this is the H3 Africa catalog. As you can see, the data is in here. It shows basically all the available studies that has been funded since the start, and yeah, that's brings me to the end of the presentation. So if you have any questions, I'll be happy to answer them.
Thank you. Thanks a lot, Ziyaad, for the presentation on FAIR principles in data management and also software. If anybody has any questions for Ziyaad and also Sara, so please post them on the chat. We'll have open discussions where we'll address these questions and also talk more about research data management. So for now, we'll take a 5 minutes break and come back for discussions, which will be moderated by Dr. Caleb Tibet, and the panel will also include Faisal and Ziyaad and Sara. So please, about 5 minutes, then we are back. In the meantime, you can also be typing your questions in the chat for Sara and Ziyaad. You'll also have the opportunity to raise your hand during the discussions and maybe ask your question. And you can also put the questions in the chat during the discussions. So please also live tweet about our event. We'll put the tags or the hashtags in the chat. Please live tweet. Let's take a 5 minutes break and we'll be back. It's 12:10 in East African time, so at 12:15 we should be back. Thank you all.
Welcome back.
Welcome back. Yeah. So right now we enter into the open discussions session where we'll be discussing more about open science, the research data management for our event today. We have Dr. Caleb Kibet who will be moderating the session. Please welcome Dr. Caleb Kibet.
Thank you, Kennedy, and thank you, Sara and Ziyaad for the presentation. And I would like to also bring on board Faisal, who in this panel. And Faisal really has been doing a lot of work in building capacity around research data management within Africa, and especially data management plans and the aspects of policies, research data management policies. And I think if you look at the concept of research data management, it really has to be anchored on a policy as well when it comes to institutional policy, regional policies, and of course, the other international policies that are in place that do guide research data management. And most institutions would be expected to have some kind of a policy. So I'd like to welcome Sara, if you're able to turn on your videos, Ziyaad as well, and Faisal to the conversation. Yes. So what I'll do is that I'll just give Faisal a few minutes, maybe 2 or 3 minutes, to just introduce research data management from policy perspective, and then we can now go into a few questions and discussions around research data management through the whole research life cycle. Thank you, Faisal.
Hi, everybody. I'm going to put the camera off because I'm sweating because there is no power since 8 o'clock. So sorry for that. Yeah. So what I'm going to give a brief an overview about research data management and mainly. Can you hear me?
Yes, we can hear you. Please go on.
Yes.
You can see so this is the element tools of research data management in the life cycle. And you have to start with data management plan at the start. You capture the data storage, metadata, as I mentioned before. And then you come, this is the creating of data, then processing the data storage, metadata, cleaning the data, analyzing the data.
Screen? Are you sharing your screen? Or we can see the slides if you're speaking. Yeah.
Can you see the slide now?
Yeah. Yes, we can. That's perfect. It's gone.
Yeah, okay. So this is the element and tool of research. I'm not going to go in detail because some have been discussed already. So creating the data, you have to, from the start of the project, even from the proposal phase, you have to write your data management plan. And there's checklist included within that data. And then how you're going to capture your data and identifying and that will include validate your data. And then you have to get rid of any sensitive data out of that, and then analyzing the data. And then again, you come to the preserving the data, how you're going to preserve it during the project and after the project, the data sharing, publishing, etc.
Thank you, Faisal. Thank you for that. So what I'm going to just, I don't know if we lost you or what happened. Faisal, you're muted and you.
Yeah, we seem to have lost him for a minute.
Yes. Faisal, if you're speaking, you're currently muted.
Can you hear me?
Yes, now we can hear you.
Yeah, so the main thing I'm going to talk about is data management policy, especially in Africa, because when Sara talked, she talked about well-established institution when they already have the policy, and then people can carry on. But when we come to African institution, there is no even research data management policy. So, so we need to think about that. And then I'm going to talk about if there is no research data management policy in your institution, what is the step that you need to ensure that have one research data management policy, because research data and change it is possible. This is some of the definition. You have to define what is research data, what you mean by research data management, often abbreviated as RDM, and what is data researcher, data repository, and access to information within your organization. Data policy overnight. You have to face it out. So first, it have to be strategy, policy, procedure, and infrastructure by training, skill development, and repository content development. And then phase 3, management and sharing of active data. And then phase 4, data selection and preservation. So if we break down this phase, in phase 1, you have to create essential documentation and infrastructure for the full-scale rollout of the RDM in your institution. You have to establish a storage facility and create repository. Sometimes some of universities don't have, or may have someone a small scale within their library. You need to scale it up according to your research potential in your institution. Phase 2 is awareness creation, skill development. This is, you have to concentrate on training, advice, and you have to develop skills for both librarian and researcher, and provide guidance for repository and data storage, and establish a data catalog. And within this phase 2, from phase 1, you have to include the librarian, because now in the North America and Europe, all of this research data management have to, the training and all the administration have to be in the hand of the librarian. Because if you have a research project have a start and end. What after the project end? So you should have think of sustainability of this research data management within your organization. The third phase is the management and sharing of active data. You make central storage available for active data. You start sharing of active data for project within your institution and even the collaborative project nationally and regionally and internationally. Phase 3 is data selection and validation. You have to develop criteria and develop agreement, a license term, as Ziyaad and Sara talk about. You have to develop preservation strategy and policy, and all these kind of things you have to include. And as I mentioned, the data management plan, they call it a dynamic document, live document, that you can start as a proposal phase and then you revisit it along the line. And why it's benefit of writing data management plan? Some of the funding agency, it is a mandate that you have to attach it to your proposal. Some it is not mandate, but they require it when you start your project, when you have been awarded the research. So it makes the research transparent, the protection and validation, as the previous speaker talk about, and hence data fairness, findable, accessible, reusable, and then protect data subject. And then you have also comply with general data protection regulation. I think this is the last thing I want to stress on, the role of the librarian in the research data management, because most of the research are funded by external funders and it have a start and end, but we need to work closely with the institutional librarian. That I think all I need to talk about. and then we go for discussion.
Thank you so much, Prof. Faisal, for that. More or less completes the whole conversation, and really we have a bigger picture from research data management, proper project organization that Sara's covered, and research data management principles, the FAIR principles from the perspective of data, and also Ziyaad also covering FAIR from the perspective of software, and also the work that the H3 BioNet actually is also doing in promoting FAIR data and software, and also H3 BioNet is also ensuring that educational resources that they are generating and putting out there are also fair. So I want to just kick off this conversation from a few questions, and we can steer the conversation as we go on. And I think what has come out is that making data either fair or more or less proper research data management practices, they are expensive, they are costly, they take time. So either time or resources, time or more or less money required to make data fair or properly manage your data. Sara, I don't know, what's your opinion for a scientist from maybe resource constraint setting? They may not have enough time to make their data fair, or even resources to make their data fair. What are your thoughts on that?
Thank you very much. So I have to admit that the time constraints has been an argument that we hear all the time. We hear from researchers regardless of where in the world they are. And time again, we do show that on the long run, it saves you time. Mm-hmm. And just starting it early on with whatever is in your means to do. So things like how you organize your data, how you name your files, how to use GitHub or other or versioning in general. These are tips and things that you can integrate in your daily life. And as I mentioned in my presentation, it becomes a habit. And mm-hmm. on the long run, it does save you time. And you're not alone and thinking that, yeah, this is how can we work with what we have, right? So there are things that can be implemented without financial cost, and while others would require a bit more financial investment. And yeah, so do what you can. That's what I try to say. Do what you can, and there's different level of fairness. Nobody will be 100% fair, not at this point. So yeah.
Absolutely. So I guess it's all about, I think, starting somewhere, and then you can be able to take it forward from there. But how can we reduce some of these barriers? What are some of the ways to reduce barriers to facilitating and enabling fairness? Because it may also be a contributor to the inequality that already exists in science. Sara?
Yeah. It's a really good question, Kayla. And I have to admit that we have to do a lot more. We have to do better to make FAIR more global. So because I do realize the dilemma of tackling FAIR from a Western perspective alone, and not taking into account that FAIR needs to be really global and needs to be applicable on a global scale in order to make benefit out of it. And we have seen an example of that as in the Vodan with the COVID sequences coming from Africa. This is an extremely important resource that we need to make fair in order for it to be reusable, because we do need an overview of what's happening with regards to COVID sequences and mutations coming from all over the world. So we're starting to really rethink our models here and try to find fair implementations that work on a global scale. So hopefully that will catch up. It's a lot more a whole lot of way to go. But what I usually say, again, start with what you can, and then we work towards making it better for everybody. Yeah.
Thank you, Sarah. Ziyaad, and with the work that you're doing in H3A Bionet in promoting FAIR, can you briefly just tell us how you are easing within the H3A Bionet, easing the adoption of FAIR principle and proper research data management practices within H3A Bionet and for the H3 Africa projects that you are supporting?
Yes, it was quite a bit of a challenge, because as the data was coming in, there was no FAIR policies in place, and during the time it was just getting the data in and getting it to EGA. There was no sort of principal process for that. So each time, so we created documentation. This is pre-FAIR days, and the challenge was afterwards to go and fix it. After the 2 or 3 year period when we already received data, was to go now and fix the data. So that was a bit of a challenge. So it's always best from the start to have, for any project, have FAIR in mind. That is the lessons that we have learned. And in terms of the catalog, so building the website, the catalog website where people can go and access data, that was less strenuous, because we already had the FAIR principles in mind when building the catalog website. So that was so we had everything in place already for that. Thank you.
Thank you, Ziyaad. Faisal, and I think I'll ask you from the perspective of also education and training. And I think you talked about one of the approaches towards making FAIR and proper research data management practices would be awareness. Can you speak a little bit to the question of the cost of making FAIR, and in terms of cost and time, and some of the awareness practices that you're undertaking to more or less demystify some of these perceptions that are already in place?
Yeah, so when we started the renewal of HC3 Bionet in 2017, we started this data management plan project, and I was assigned with Samir to co-lead this project. We used to train people on data management plan, but after 2-3 years, we came to conclusion there is a gap in overall research data management in Africa. That's why in June from last year, we started designing a syllabus, and Ziyaad with us and others within HC3 Bionet to have research data management short course aligned with international workshop and requirement, but also aligned to the African perspective, and getting the experience of what Ziyaad have skills in archive and iTunes and other people within HC3 Africa. We run that for 4 years, and we are going to run it next year also. The other thing that what I agree with Sara, that if it's a small project, you work with whatever you have. But we are lucky that we have a big project like HC3 Africa and HC3 Bionet, funded by NIH and some of the project for HC3 Africa by Wellcome Trust. The funding agency nowadays, when I talk about the data management plan, within the data management plan, if it's mandated by the funding agency or not, you have to attach it for the proposal, and you have to budget out cost of data management and how to make it fair. Because nowadays the funding agency they will fund that, but unless you put it in the data management plan and then include it in overall budget of your proposal, if you are applying for a big funding agency. But if it is local, then I agree with Sara that you start with whatever you have and then build on it. As I mentioned, with the policy, you can't do it overnight. You have to start small and scale it up until you go early. But believe me, the fairness process is not only Africa, it's all over. It's still a new thing. and it needs funding and it needs people to work together. I was in a meeting last week with RDA. We want to send FAIR questionnaire to most of the hospitals all over the world. And we are talking for half an hour. Do we, I was wondering at that meeting, when I asked someone who is a doctor in a hospital about FAIR, my thinking and my thought, not all doctors know what is FAIR. So you have to include that in the questionnaire, gives them link what is FAIR is. So that will return us back to training and awareness. When I talk about the policy, you can't implement a policy unless you prepare the people who are going to implement it through awareness and training. And that's what is SC3 BioNet have been doing in the last 9 and now we are in the last 10 years. Thank you.
Thank you so much. And I think you bring about something really, really useful there. The role of data management plans in all these research data management plans, because that's where you can be able to budget for resources to make the data fair, resources to share the data, resources to prepare the data for sharing. And I think that's actually really, really important. And some of the barriers to adoption of some of these practices would be some of those lack of policies. So thank you for that. Sara, you talked about, and I think there's a question you already started answering. And I think many people, when it comes to the concepts of embargo, and also as a scientist, I would want to derive as much value as possible from the data that I'm sharing out there. And especially if you're coming in from a resource constrained setting, you may not have enough resources to analyze the data really fast and be able to generate insight from the data, publish and make progress in your career. Can you speak a little bit to that? Embargoes and the fact that some may not be able to actually analyze the data fast. What can they do to still be fair and open?
Right. So first of all, I just want to agree with Faisal on the points that he raised. That was really interesting because it is a point of view that's not talked about much, that there overall on a global scale, FAIR needs a lot more work. So this is very important, and it's the extremely important role for raising awareness and so forth. And I think there is indeed a very strong push from funders to include budgeting details for how research data management will be carried out. So that's we are seeing progress on a global level, but we're not there yet. So thank you, Faisal, for raising this point. And yeah, regarding deriving as much benefit out of the research data, we have to realize that data on its own has an inherent value, whether it's used and analyzed at this point in time or in 20 years' time. And what we don't often consider is that data one data set in combination with another might be extremely beneficial. And we've seen examples of that in early days. For instance, combining data of mapping data of a city wastewater to COVID spread, and how the wastewater workflows and the piping, like that's geographical data of how that works. Combine that with the spread of the COVID virus has given us an important insight of the viral spread. So in other words, what I'm trying to say is, once you realize that the data in itself has a value, putting it out there, whether it's analyzed or not, and claiming your ownerships on it and adding clear licenses, allowing others to reuse it, will essentially feed back to increasing your profile and highlighting your profile and your work a lot more, because at the end of the day, you're the owner of that data. And once you put it out there saying, I proclaim it, anyone else who wants to use it will have to cite you, it will raise your profile, will want to work with you because it's a good data set. So you don't need to wait till you have everything derived at all, or done all of the analysis yourself. Allow others to help lift you up as well. I hope that answers your question.
Thank you, Sarah. Yes, it does.
Can I add something here? I agree
Yes.
with Sarah, is that COVID-19 and before COVID, Ebola also changed the way of open science. Fewer people start working with open science, but with Ebola, how it spread in West Africa, and then now COVID-19, that changed the perspective. It is not Africa problem only, it is global problem, and we need to work together. And that put the standard that every continent, every country matters. And that changed the parameter. Yeah.
Absolutely. It is a global issue, and the benefit is also global. When data is shared, it really does push science forward. And I think talking about the benefit of science, it's to all of us, it's to solve some of these global problems. And just still going back to that aspect of, so there's a concept of as open as possible, as close where necessary. And the fact, of course, that FAIR is really not equal to open in itself. Can you really expound that a little bit more? So you're dealing with, you have maybe, for example, a student, and most of the time they do not have control over the data. So this student still wants to be fair and to some level open, but their advisors probably would still want to have strong control and close the data. What are some of the options available to them to still ensure that they are still fair and open to some level? Start with Sarah, then Ziyaad.
Right. So I get this question a lot while teaching PhD students in Germany or in Sweden or other countries. And is there still a mindset of, I want to share, but I'm not sure my supervisor will agree. And it's so painful to see. And, you know, in case, you know, the old saying of, it was a saying from Max Planck, actually, something to the effect of, science progresses one funeral at a time. We're kind of waiting for the older generation who's opposed to that to move on so we can have the newer generation with new ideas, fresh ideas, with more openness and fairness to take over. But we don't have to. We don't have to wait that long. That's where policies come into play. So when I get this question from PhD students, they say, well, if your supervisor doesn't want that, check what your funder's requirements are, check what, as an institutional, there's an institutional requirement, for instance, in this institute, that to share openly. So it doesn't necessarily mean that just because your boss says no, that it's a solid no. And come to us, talk to us through a research data management office, and we can help push forward that agenda with you. You're not alone. So, but this is again in a place where you do have some open science commitments, you have some regulations in place or policies in place. So I will let Faisal answer the second part when you don't have this in place, what to do.
Yeah. So Ziyaad, then Faisal on the same question. Ziyaad, you're muted.
Yeah, so it is quite a challenge if it is not in place. But I guess the main thing is to go and get it into the people that and make sure that they know that they need to go and follow the standards accordingly for FAIR, so that it can go accordingly and into the right place. and therefore help with the wider audience in terms of getting the data out there.
Faisal, especially when you do not have a policy, what do you do?
You started. I can distribute those phase out to people, and then there is some paper I can send it out. So you have to start it. And the thing is, we need to change the mindset. For me, when I came back from Canada in Africa, we established a FAIR School of Medicine in Botswana. There is a decision that by 2025, they want University of Botswana to be research intensive.
Mm-hmm.
So you can't start overnight. You have to start 10 years before your goal. If you say that by 2030, I want, for example, University of Khartoum to be research intensive, I can't wait until 2030. I need to start 10 years, 5 years before, and then I have to, as I mentioned, phase it out, this phase of establishing the policy, train the people, change the mindset. And the thing is, people don't want to share their data or to be fair because they have been working in isolation. But the moment they start having regional or international grant, that grant will lend them the hard way. You get my point. But when you are just within your restricted zone, you're not going to be, you need to catch what the global research operate on open science, open access. For example, we have one paper I can share. Unfortunately, it is still not open, but we are trying to make it open about the data management plan. So I guess we are trying now to pay for it. But even when you want to make it open access, is very costly. Do you believe to make this paper? We asked for it to be open, but the editor, because he put us in a special communication. By default, all special communication is not open access. And they, 4 weeks ago, they published it. And when we asked them, oh, this is not open access. And then we start emailing and trying to change it, and it will be changed for open access. So open access itself, as I mentioned before, is not easy, it's not cheap. And that will return us back. You have to involve with regional international funding agency, because you can budget it in your budget of the project that you want to publish. The first year of the project, you can't publish because you're still establishing your team or research and etc. But from the second year, you have to budget item for publication. And so that thing will help you that, oh, the funding agency wanted to be open access. So I need to put that in the budget. So changing the mindset of the regional institution and training and educate people before the goal that you put in 2030, you want to be a research intensive. Thank you.
Thank you, Faisal. I think you really raised some really important issues there. And the fact that, yes, we may not be there yet. We are not there yet. But we are part of that generation that are pushing towards that. And it's our responsibility to work towards that by changing the culture, starting those practices. And I think I want to highlight the concept that really sharing, and which is always the restrictive aspect, is what happens at the very end. But when it comes to proper research data management practices, you can practice those ones through your research, but it doesn't mean you're going to share, you're already sharing your data, but it prepares you to the time when you need to share your data, because you already utilizing proper research data management practices, you've applied the FAIR principles. And in the end, if you can be able to convince your supervisor, when you need to publish, most of the publications would actually require that your data is shared.
Can I add something here?
Yes,
can I add
please,
something here? Yeah,
please,
that's the thing you have to, if you start by yourself, then you will be focal point for others to come to ask, because you've done it. And if you've done it with external collaboration, and then people within your country, within your institution, they will come to you, and then you will be the focal point. I remember that in 2019, there is HCRE meeting in Tunisia, and I'll present best practice for, I can share out also, best practice for data management. And then let me just show you. And then my philosophy is that, because we planned from 2017 that we have been optimistic that the HCCRE Africa BIs will provide us with data management plan of their project. But turn out that is not the case, because some of them don't have one. But the thing is, I made that poster, and during presentation, people come and ask me about it, what is it? And then I put aside paper and ask anybody if you need a copy of it. I can send him PDF. My vision is that when he went back to his office or his lab, he can print it as a poster and stick it in the wall. I want the BI to see it every day and night, and that a way of, we have sometimes push from bottom up and sometimes from top to bottom until we realize what we are asking for. Because it's not easy to convince people. But if you put it, and then those who have this, if they start doing it for their project, even for a master, it's not necessary just for a project, operation project, even for a master and PhD, if you start that practice, believe me, you will be pioneer in that area. Yeah.
Absolutely. Yeah. Thank you so much. I think you've actually already answered the question that I was heading to, and the change of culture. How do we, what are some of the other, also the ways that we can change the culture within our institutions? And Sara, if you'd like to speak to that.
So changing the culture towards more openly sharing, fair practice culture.
Yeah.
It's a challenge. It's not an easy one. But there's hope, and there's advances in that terms. There is a lot of awareness raising and championing from data stewards, from research data managers, from librarians, from research support staff. So and that is combined with the requirements from higher up. So we are seeing a lot of bottom up grassroots approaches as well, like communities that are blossoming in a lot of countries and gaining more support, and that is supported by the mandates coming from top down. So it's going there. It's not where we wanted, but I think what really does leave a very strong impression in the younger generation is seeing, and this is something I get asked a lot as well, like, do we have examples of prominent researchers who are adhering with open and fair principles? And that's where it comes to. We need more of those champions. We need more of those people to showcase that, yes, you can be prominent, you can have a huge impact in the research community and in science as a whole, while being open and fair. So I think it's a combination of approaches. So as Faisal mentioned, like, you just need to start, and that will in itself will create the momentum of the people around you to join you. And at the same time, we need people who are willing to showcase a good example and good practices of how to do it.
Absolutely. Thank you so much. I think we're heading to the end of our time, and I just want to give each of you just a minute or so to, what's the take home, what's the message, just the final message, and when it comes to research data management from this, what's the take home from this conversation, and also from your presentations? Ziyaad, can you start with you?
Yeah, the take-home message will probably be, if it's not now, then it's never. So if you want to get your data out there, start doing it as soon as you can. That's the only way it will happen. Yeah, thank you.
Thank you. Thank you so much, Ziyaad. Faisal?
Yeah, I think, can I share also, just I'm trying to promote HC3 binding. Yeah, by promotion, by training, we have in the website of HC3 binding under the data and standards, we have data management plan, we have tools and resources. You can spread the word and share it within your institution. And there is link for not only HC3 bind, international also. There is 10 symbol rules, and there is all this sign, even clinical data management. That another aspect is not genomic research only. There is clinical data management, and even nowadays they are start talking about not data management. They are talking about clinical data science. You get my point?
Mm-hmm.
In one of our HCC Bionet webinar within HCC data management plan, we have discussion papers. And one of it, there is one paper from the Society of Clinical Data Management. They have very nice annual report and paper. And they have part 1 and part 2 about talking about the shift and the evolution from clinical data management to clinical data science, because there is element of artificial intelligence, machine learning, deep learning coming, and telemedicine. So all of these, they are going to change it from clinical data management to clinical data science. And then you have the expert domain within each field of medicine. They have to work together with the computer scientists, with the imaging also itself for the brain research, etc. All this kind of thing, and the hospital. So things are changing to clinical data science. Thank you.
Thank you so much, Faisal. Sara?
Yeah, so some things I would say, first of all, yeah, just go for it. Just do what you can do. Things are developing on a larger scale. We're not there yet where we want to be. There's a lot of development. You're not alone in thinking, how do I do this? There are other people all over the globe asking themselves the same question. How do I actually do this in real life and implement it properly? So, but do what you can now, and that will save you time in the long run. Do share your data, because that's how you leave your mark. Share your data. Do not underestimate the value of your data on its own, and go for it. And I would say to find support, join communities, find out what other people are doing in your own local community and on an international level. So H3 Bionet, definitely, I think Faisal shared already the things that they're doing. Join also Turing Way to find out more about reproducibility and how to achieve reusability and reproducibility. I think you'll have this tomorrow, if I'm not mistaken. So there are a lot of work in the field. Go for it, join it, and start it just as soon as you can.
Absolutely, absolutely, absolutely. You are not alone. There's so many initiatives and communities now, including even the initiative that we are having, these boss events, and all those, they are aimed on one, creating awareness, and later on for the workshops, you'll also provide some training that would support and facilitate the adoption of some of these practices, making your data fair, proper result data management, proper software versioning, and it's really, really important to take advantage of all these communities that are already well established. And thank you so much. At that juncture, I would like to hand it over back to Kennedy as we wind down our conversation today.
Thank you, Caleb. I'd like to thank Sara, Ziyaad, and Faisal for the presentations and the discussions. Thank you, Caleb, for moderating the discussions, and thank you all for attending today's event on research data management. So we will have a group photo